Hello everyone, and welcome to a discussion on free online analytics environments. So why talk about online analytics environments, and especially free ones? And we'll go over that, but the short answer is sometimes you need to be able to do work where you're at, not necessarily on your home laptop or desktop. So with that in mind, we'll go over kind of the motivation of doing online environments. We'll explore several of them, focusing on languages. So Python, taking a look at both Google Colab and Databricks Community Edition, and then focusing in on R as well with RStudio.cloud, and also Google Colab with R notebooks and Databricks supporting R. Then we'll close with my recommendation. So moving in, why bother? And the short answer is you can't always have access to your information. While you can do certain things such as put your files on a cloud drive of some sort, be it OneDrive or Google Drive, there's still oftentimes challenges being able to do analytics anywhere you're at. Also, sometimes you can't necessarily put software on your work computer for obvious reasons. So sometimes you need a low impact way of doing development, and also you may want to be doing some collaboration, and several of these tools support that as well, so that more than one person can work on a given notebook or project together, basically being able to leverage maybe expertise in a field that's not necessarily physically located where you're at. Sometimes it's just easier. Maybe it's more convenient, especially if you're working inside of a notebook paradigm. There's not much difference between working on a local notebook and working in a cloud-based notebook. And everything I talk about here are free, with some limitations in certain situations. So there may be consumption limits and so on, but they are free as far as initial usage. And also you can potentially pay for additional alternatives as well, but I'm focusing on free because free is good. Moving into Python, very common language, especially in the data science world. And the first kind of offering to look at with regards to Python is Google Colab. So moving into what Google Colab is, and it stands for Collaborate, and it is a online hosted notebook offering, leveraging and tied into the other Google offerings such as Google Docs and various other offerings, so that it allows you to do what you would expect, have notebooks in the cloud. It's actually a very nice environment. It's very well done. The editing is top notch. You get a certain amount of what you see, what you get sort of editing of your markdown. And the Python seems to be reasonable from the offering, especially from an introductory data science sort of perspective, even up into some middle level, doing potentially classification, a few other things. And so it is a reasonable environment. You go to it by going to the URL at the top of the page there, collab.research.google.com, or if you search for in Google, no surprise here, Collab Research or Collab Google, you'll find it pretty quickly. So there's several approaches you can use. One is obviously you can go and create your own notebook. Also, a nice feature though is it allows you to upload an existing notebook, so you have the ability to go to the file menu, select upload notebook, and then basically navigate to your local drive and upload a notebook. It does support the common Jupyter sort of notebooks, and does a nice job transporting it over. In this case, you can see an example of a Python notebook that I wrote that basically is dealing with the Titanic data set. And so a nice sort of look and feel to it. One of the things that you're probably going to want to do is upload some data. So I showed you how to upload a notebook. You could also obviously create a new notebook and fill it in from scratch. But most of the time, you're not just writing a notebook. You need some data. So there's several ways to do it. The four that I've identified here are pretty good. You can upload it to temporary storage using the UI. You can read it from a URL, probably the best approach for many situations, assuming that the data is not prohibitively large. Or you can also upload it from your local drive via code. So there's some code that you can write that'll do that. We'll talk about that in a moment. And then the last is to mount the Google Drive. So to upload it from a temporarily into the storage, you basically just click on the little folder on the left, click on the upload, navigate to the file that you're interested in uploading, and it shows up. And then from that point, you can basically access it from code. So very straightforward. I'm doing here is a little preview that it's got built in so that it'll show you the tabular representation as well. And so that, again, click on the little folder over here, click on upload at the very top, navigate within your file system to your file and pick it. And then at the point that you go to access it, it's as easy as referencing it from that name. So really straightforward. The downside of that approach is that it will go away at the point that your session ends. So at the point you close this web browser or you stop editing it for a certain period of time, that file goes into the ether. It's no longer existing because they basically are tearing down whatever containerization they're utilizing to offer this particular essentially a virtual machine to you. And you notice here you can see you got a little visual into how much memory and disk you're using. Very, very nice environment. You can also potentially, well, this is showing you how to access the file. Again, no relative path or anything else. You're basically just saying the pandas.read CSV and you get your data file. So very straightforward. Another approach, and this is not a bad one to consider in general, for one of the classes I teach, I uploaded pretty much all of the data files that are needed throughout the course. Includes the typical Iris CSV, the Titanic, the GAFA data set, which is the Google, Amazon, Apple, and Facebook stock prices, and then the Rossmann stores sales data for training and so on. So this is a relatively easy way of doing it. The top example shows you pretty much the approach. You have the URL, and this is all out on GitHub so that it's accessible by anyone with these URLs. And you can just call read and give it the URL. And then you've got the file into memory. This approach works on pretty much all of the environments that we talk about here, and not a bad one because you simply don't have to mess with uploading the file. The downside of this approach obviously is that you are transferring that file across. It's going to have limitations on certain sizes. For these files, it's perfectly fine. Another approach is to basically read from the Google Drive. So if you've into Google Colab, you've obviously got a Google account, so you've also probably got a Google Drive. You basically put your data into the Google Drive. And then you run the code that's here. Basically, you import files from Google.Colab, and then you call files.upload, and essentially the file is you choose the file, and then basically it's ready for consumption. So pretty straightforward. A little more work than just hitting the URL, but would work obviously with bigger files. Another approach is to do file upload. So this is a similar sort of approach. This allows you to navigate to the file, pick it, and you've got the file up into space. You can also mount the Google Drive, a very simple approach to do as well. It gives you basically a magic sort of link so that you are doing this OAuth basically authorization to say that it's okay for it to access your drive, which is very nice that even though you're dealing with two Google services, you're having to give permission for Collab to access your drive. And then once you've done so, you get back a magic string that you copy over into the other notebook. And a bit of a slow pause here. My network was crawling whenever I recorded this particular screenshot. So you copy that string that you get back and into the other notebook over on this notebook, and into this text box that it gives you whenever you hit this line. Once you've done that, you've then mounted the drive, and then you can access it in several different ways. So that is the easiest in a lot of ways, because then you've got it over here. It just shows up as my drive, and inside of the data, this is everything that's on this particular Google Drive that I have. Same basic files as what is on the URL. Moving on to the Databricks Community Edition. It's accessible from community.cloud.databricks.com. It's intended for people to learn how to use Spark. That's kind of the purpose. But it also is a great place to do some notebook, and maybe you want to eventually stray into using some Spark over time. It is free, but there are some limitations. It's a single node cluster, but there is no limit on the amount of compute you're getting on that single node cluster. So it's a very simple sort of thing to interact with. Databricks supports the 4 different languages you see on the screen: Python, R, Scala, and SQL. It does have storage, but the interaction, because it is the community edition of Databricks, is a little more challenging from native, say, Python to access the storage systems that are available to you inside of Databricks. So instead, you may want to go with the URL route, or you can potentially explore Koalas, which is a Spark-friendly version of Pandas, is the best way to think of it. So you could potentially start transitioning into writing Spark code through that approach. Pandas is something that works on a single node. In this case, for Community Edition of Databricks, it's not a big deal, but if you have a real cluster in Databricks, you don't want to use Pandas because everything's going to be limited to the driver node. So instead, you would want to use some other approach like Koalas. The first thing you want to do is create a cluster. Afterwards, you'll want to start it up whenever you enter your site. And you do actually have to go through kind of an explicit cluster creation where it happens for you in a little easier way when we talk about Google Colab. So Databricks Community Edition is free. It's intended to learn Spark. Does allow you to upload files. This is what the screen looks like whenever you first go there. So you basically have to sign up, and you sign up by giving the typical username and password and a few pieces of information so that they can potentially market to you. And then once you've done all of this, you'll receive an email that allows you to activate it. And in this case, I'm just basically filling this out, so I'm setting up an account so you can see it. And then you don't have to give a email or phone number, and you can choose to opt into the marketing information. Then you're presented with basically kind of the decision point. You can go with the Community Edition, which is free, or you can go with AWS, Google Cloud, or Azure's offering of Databricks. These are the full-fledged things. It's not limited in any way. But it is also not free. So the free is the Community Edition, likely something you'd want to go with. Then once you get in, you're going to get a link where you've got to click on a link to validate, and then at that point you're assigning a password. So it does email you a link that you click on to come back in to kind of complete the registration. It's got to be at least 8 characters. Not terribly complex, but a reasonable password. And then once you've done that, you're into Databricks. So it's provisioned an account, and again, totally free. And once you get in, you land on the landing page. This is where you pretty much do all of your work. And so, again, the intent here is to try to encourage you to go to a paid version of Databricks. Given that's not the intent of this exercise, you want to probably stay with the free one. First thing you do is go through and create a cluster. A cluster has a name and a specific version of the runtime, and not all of them are necessarily going to be available to you that are in this list. I found that out. Also, you have availability zones. It's limited to the West Coast, and there are 3 that you can pick between. While it's going through the process of creating a cluster, I go ahead and create a notebook. And basically, it's just to show load data, and you associate it with the cluster that you just created. So you see there, upper left-hand corner, it was linked to the first cluster I created. And here's some code that's reading off that URL approached off of the GitHub account, and basically loads the data set into memory. And then from that point on, it's pretty much plain old Python if you're so inclined. So definitely a good environment to consider. This is just kind of the tip of the iceberg of what you can actually do inside of Databricks, but it is something to kind of keep in mind and get out there and know that it is available from an analytics perspective, so that there are online services available for free that you may want to consider. And you can see right there I selected the cluster that it's tied to and the language. This is where you would select a different language, such as R. The other very common language in the data science community is R, less so than it once was, but still quite relevant. It is a very established and mature environment, very, very nice in a lot of ways, but it also is a bit dated and it doesn't have the excitement around it that Python is typically getting these days. So the first option to consider for R is RStudio.cloud, and this is a really interesting sort of thing. You can do something similar to this if you have a paid version of Databricks. You can actually install essentially RStudio onto your own version, onto your own cluster. Not something you can do with the free edition, but it does include storage, and the nice thing with it is once you get past the logon screen, it looks pretty much like RStudio. It's kind of hard to tell the difference. So when you land on RStudio.cloud, you either need to log in or sign up for an account. Keep in mind that if you do sign up for an account, you are limited here to 15 project hours per month. So be cautious of how much you're using here, because their intent is to make money off of this. Your intent probably is to not pay. So if that's the case, then be frugal with your work. Make sure that if you're using it, you don't necessarily spend a lot of time on it. That being said, for a lot of the courses, 2 full 8-hour days or a little bit under of coding is probably more than a lot of people spend on their assignments. But from as a secondary sort of alternative, not a bad idea. It is, though, something that you could end up having to pay for pretty quickly. There is also a bit of an educational discount for instructors. So something to consider. Keep in mind the price. Whenever you go through the sign-up process, it asks you which one do you want. You go for the free one, and you could pay an extra $5 a month and get 50 project hours per month. Not a bad deal, depending upon what you needed to do. Then you go through the typical sort of process of signing up with an email address, password, or you can link in with your Google account. So I'm, in this case, signing in with a Google account, and it's essentially allowing me to do the unified authentications, and I'm basically giving it a name that is unique to that account and creating an account. And then you land on a page where you need to create a project. So this is the splash page. That the next step is to go through and create a new project. You give the project a name. Project is kind of a collection of things. I named mine something like DO2 for deliverable 2. You might just create something called analytics work, because inside of a project you have files. So the first thing, once this actually goes through the process of creating it, is you can then turn around and create an R script. So it goes through the process, provisioning, setting up the environment, and you can kind of see just it's a fairly clean sort of environment. There are some helpers out here. You've got a cheat sheet, some primers, some getting started, a guide. And once it comes up, looks a lot like RStudio, right? There's a little bit of differences in through here, but not much. This is the nice thing where you can actually upload your data in an easy to use way. In this case, I'll upload the Titanic data set. Click OK, and it drops it into this folder, into this cloud project folder. And then I'm going ahead for fun and sticking Iris in there as well. And so once that's done, then it's a matter of potentially creating a script. I just take a quick look at the file to see what it looks like, and you can see that it dumps it out. So it is there and accessible. And you may have to install some libraries along the way. So I was going to do an import. That's going to take a little bit for it to go ahead and set itself up. Your next step is to go and create a script. It's going through the process of doing the installation. It's like very much like R. In fact, underneath of tools, you can go to CRAN and search for things and install it just like you do in RStudio. So again, not a bad option. Pretty easy to use. Very familiar. If you know RStudio, you know RStudio.cloud. So very compelling. And through here, it's basically showing the code or generating the code from that import, and after it did the load, and so on. So moving on to creating a script. The next thing you'd want to do probably is go in and create a script file, and then save it with some name, and it'll be saved inside of this kind of file system up here on the cloud. You can export it and download the script after you're done, which is something you'd want to do most likely. so that you could turn it in. Once you create a script, you can basically go ahead and run it, and similar to what you do in RStudio, and you can see that the output coming to the screen here. Then the last step that you're probably going to want to do is export it. So make sure it's saved. Click over here, click on the three dots, or I'm sorry, the more, and then click on export, and it allows you to download your R script so that you could then, say, turn it in if you're doing something for a class assignment. So again, a very friendly sort of environment, nice, easy to use, looks just like RStudio. And again, you can actually do this same thing if you have access to, say, an Azure, AWS, or Google Cloud account with Databricks installed. You can actually install RStudio into the cluster, and it looks just like this. So something to consider. Another alternative is to use Google Colab, which we just talked about for the Python side of things, but for R, it's a little less elegant than you would like because there's no file create R notebook. You have to know this magic URL. So collab.to/R, and it lands you on a page where you've created an R notebook. So does support it. It's not bad support, but it isn't what you would say first class support. It's almost like a secret menu, if you will. So you have to know to ask for it. You could also use the rpy2 package and basically put the %% kind of magic string at the beginning of each cell. Really kind of clunky way to do it, but you could do that. This is using the R runtime, and pretty nice once you get past the initial creation of a notebook. Keep in mind, though, if you were to say file new, create, you're going to be creating a Python notebook, not an R notebook, even though you're looking at R here. So something to keep in mind. This is an example of it running, and notice the data. You have the same sort of thing. You upload your data into that file folder location, and then it does remind you, hey, it's going to go away at the end of this session, and then you can click on it to take a look at it, and then it's the same sort of code to basically load it in as well. So moving on to actually loading it, you do the add a cell below by clicking on at the bottom, and I'm just basically just loading the iris data set, and notice the beginning slash, so I'm saying it's in the root because I'm being pretty ugly over here, but just dropping it into the root of the file system since it's transient, so what's it matter, right? Although that is kind of a bad habit to get into. So, and at this point I'm just showing you the number of rows, showing that it actually did load it into memory. It is, though, pretty cool, so something to consider. You'll likely need to install some libraries. You'll probably want to do install.packages and then the name of the package to get things to work. Then obviously the same sort of referencing that you normally do, and that is a typical sort of pattern that you'll see. So install.packages is your friend. Also, if you want to see the graph, make sure you put a line to make sure it evaluates. It's not going to show that you created a graph here, assigned it to G2, unless you actually evaluate G2 to see the results. That being said, you definitely can do the same sort of graphing stuff, and you can also save off to the same sort of file, so you can save it into that file structure if you're so inclined. Moving over to Databricks Community Edition and with its support for R. So Databricks, as I've mentioned before, supports multiple languages. In this case, you can pick R as the language for the notebook whenever you create it. You associate it with a cluster, and then it's typically just the same sort of thing. You write your R inside of this cell and run it. It is a little potentially challenging if you don't use the URL to retrieve the data, because you'll have to go through some hurdles to get it into something that you can access. So if you basically are using the URL approach to loading your data, no worries, it's great. If you want to read it off of a temporary file location inside of Databricks, a bit more of a challenge, so something to consider. Definitely viable, but definitely a good experience. I could talk a lot more about Databricks, big fan. This particular case, there are a few challenges, and it's primarily because we're not doing Spark. We're just doing straight up R. So moving on to my recommendation, and based upon which of the languages you're using is the key thing. So if you're doing RStudio, is the best choice for R. So if you're doing the R language, you probably want to do RStudio.cloud. Do keep in mind, though, the limitations associated with the costing and so on. But the part of the reason for that recommendation is identical to basically to what you're running locally. So very smooth transition in a distributed online sort of approach. So you could access it from anywhere versus having to reinstall RStudio on some other computer. It's probably good for most users. If you can't do RStudio.cloud, then go to Databricks, because Databricks would be your best choice after that. In my opinion, the reason I'm not a big fan of the Google Colab R support is you got to have the magic URL and remember to use it, and it's just a bit clunky. For Python, hands down Google Colab. It is just really nice, really easy to use, very pretty, very elegant interface whenever you're using it. It just kind of works right. And the fact that it is highly integrated with things like Google Drive, very compelling as well, so that you can have your files in one location and not have to be too concerned with it. So if you had some data in a spreadsheet, easy enough to get it to a CSV and then pull it into Google Colab for analysis. After, if you're not going to use Google Colab, then I'd go to Databricks and use a URL approach. And that concludes the recommendations. Here's some links to the various resources, especially those CSV files that I uploaded that might be of interest to a select set of the audience. As always, if you have any questions, let me know. That's what I'm here for. Stay safe, and I'll talk with you soon.